Okay, so working with similar triangle hopes to answer questions kind of like this, which is, this is like, I don't know why we need to know this. We want to find the height of a tree, but I compare that to how tall the person is. Or another case of finding the height of a tree. So those are kinds of things that we would use with similar triangles. So let's get to it. So let's kind of review what congruence means. Congruence means that two or more figures have the same shape and the same size. So what does similar mean for similar polygons? Similarity, they have the same shape. So if you notice what's missing, size does not have to be the same. So they are the same shape, but not necessarily the same size. They are proportional. That's how we think about it. And we use this little symbol here, the little, I guess that's called a tilde. That means similarity. So congruence is the equal with the little tilde. When you're using similarity, you just have this guy, no equal sign, because they're not the same size. So all congruent figures are similar, but not all similar figures are congruent. So if you're congruent, because you are the same shape, you will be similar. But if you're similar just because you're the same shape, you don't have to be the same size. So maybe picturing like triangles like this, which are the same shape, but they're not the same size. That's what similarity does. Proportional. So when you have similar polygons, corresponding angles are congruent. Okay, that's just like when we did similar or congruent triangles. All the angles are congruent. However, the sides are in proportion. So we use something called scale factor. Now I know you've heard of scale factor before when we have done things like scale drawings and even last class looking at a scale on a map. A scale factor. A scale factor is the common ratio of the corresponding sides. So instead of saying corresponding sides are congruent, like we do with congruent figures, we say the corresponding sides have a common ratio. And that means they're in proportion. So these are two similar triangles here. Look how the angles all match. The angles are all congruent. Okay? But the sides are not all congruent. However, if I look at the scale factor of all the sides, AB to DE, right, those are corresponding sides, AC to DF, corresponding sides, and BC to EF, they're all going to be equal. And let's make sure we see that. AB, oops, that's this one, to DE is 5 over 10. Oh, that's this one. I don't know the word here. AC to DF is 3 over 6. And BC to EF is 4 over 8. They all equal a half. So when you have that situation where all the sides have the same scale factor, in this case that scale factor is a half, then you have similar triangles. All the angles are congruent and all the sides are in proportion. Yes? No. There's no implied order. I can put this over here. How I say this matters. If you're going 1 to 2, I'm going small to big. That's how I'm stating the scale factor. If they said, what's the scale factor from the big triangle to the small triangle, it would be 2 to 1. So the order that you're kind of looking at it kind of matters. We always write our scale factors in simplest form like any fraction. Okay, so some examples. We want to find the scale factor of this figure over here. I'm trying to see this one. Yeah, this one's on your paper here. Example A on page 1. So how do I find the scale factor? First of all, where are all the corresponding sides? Luckily, these do have the same orientation. I can tell by the angles. So they're all kind of lined up in the same way, corresponding sides. So this one, FJ and ZW are corresponding sides. So there's a scale factor. And I can reduce that, which becomes, I want to say 4/5. I want to check all the sides. All the sides have to have the same scale factor. So let me just make sure. So JH to WX, that's 12 to 15. Let's see, that's 5 by 3 divided by 3. Also 4/5, that's good. Scale factor from GH to XY, that's 24 to 30. Divide both sides, yeah, by 6 here. So that's what, 4/5, good. And then my last side here is 20, 25, right, actually, to ZY, So see, I've got all the same scale factors. These are similar triangles. The scale factor from the small figure to the big figure is 4/5. If I wanted the scale factor from the big figure to the small figure, it would be 5/4. At this one, I just went in the order they were presented to me left to right. But you're right, you don't necessarily know. So you would state the scale factor from FGH2, FGHJ to ZYXW is. So if you state the similarity, then it's clear. So the way we would write this as similar figures, we would say FJGH is similar, use that little guide, to ZW, let me write this correctly. I didn't write that correctly. Sorry. There you go, FJHG. And then I go around the same way, ZWXY. And just like in the congruent statements, these have to be the corresponding vertices so that you can tell that FJ and DW are the ones that need to be in proportion. JH and WX need to be in proportion. Okay, so that's how you write a similarity statement, just using that little guide. Okay, let's see if we can figure out if these figures are similar. The way you do that is you look, do they have the same scale factor? Now this one, they are not necessarily situated in the same order. And the way you can kind of tell, well, what goes with what, is I kind of look at the side, relative sides. Like this is the smallest side, and this is the largest side. Then I look over here, well, here's my smallest side, and here's my largest side. So if I want to see if they're in proportion, compare small to small, which would be 6 to 3, which is in a 2-to-1 ratio. And then let's compare large to large. Large is 8 to 6. Which is, I think that's like a 43. So do they all have the same scale factor? No. So these are not similar figures because I don't have the same scale factor all around. It's kind of important to match up, and it can be a little difficult sometimes what matches with what. So using relative size is one way to kind of figure out where the corresponding sides are. Okay, you're telling me, oh yeah, question? Yeah? Well, don't go by books. I'm glad you asked that. Don't go by books. Just like with people, right? Don't go by what they look like. You have to know them. Same with these figures. Now, it definitely looks like, well, look, this one and this one, they don't look like they're in proportion. But all I have to do is change a number, and I can make these things be similar, right? So don't go by what they look like. Well, that's what we did. We looked at the numbers. That's different. Looking at the numbers is exactly what you want to do. Okay, these are similar. D, E, F, B, E, F, this way, similar to N and P. And I am comparing that, okay, you know, we're in the same kind of orientation. Find X. Alrighty. So I know D, E, and N, N are similar, or corresponding sides. So that's a 9 to 12 ratio. Let me reduce that, 3/4. I'm just going to check just to make sure. 12 to 16, does that work too? Divide by 4. Okay, good. This is my scale factor. So that means from the small to the big triangle is 3 to 4. So that means from X to its corresponding side, which is the 20, is also going to be the 3 to 4. So we set up that proportion. So this times this equals that times that. So 4X equals 3 times 20. Let's just divide by 4 here, divide by 4 here. It looks like X is going to be 15 because that will give you that 3 to 4 ratio that we need. Makes sense, not make sense. What do you think? Yeah, okay. It's not enough? Yeah, okay, good. That's always good. Perimeters and scale factors, an interesting thing about perimeters is that if two polygons are similar, so you have that situation, all the angles are congruent and all the sides are in proportion, then the ratio of their perimeters is equal to the ratio of the corresponding side lengths, which means they have the same scale factor as the sides. Perimeters have same scale factor as the sides. Basically what that's saying. So I've got this polygon here, and let's see where we are. We're on the bottom of page 1. Polygon A, B, C, D, E. So I've got 5 sides here. And it looks like I'm missing things here. F, G, H, J, J, K, they are similar. Oh, this is J in the next two. Find X, and then find the perimeter. These look like the same orientation. A goes with F, B goes with G, C goes with H. So I don't have to worry about who goes with what, because 10 to 15 will be a corresponding side. And so I can reduce that and divide by 5. So it looks like the scale factor from the small figure to the big figure is 2 to 3. And they're telling me they're similar, so I'm allowed to assume that's going to be the scale factor for all of them. So if I want to find X, here's his corresponding side. So X to 18 also has to have that scale factor of 2 to 3. So I set up that proportion, and then I solve it. So 3X is the same as 2 times 18. Divide by 3, 6, looks like X is 12. Okay. And then that's 1. Now they want us to find the perimeter. So instead of, you could go and try and figure out what every side is, but that's one way to do it. It's got that same scale factor. So I can find the perimeter of this guy by just adding up the sides. So somebody add up all the sides for me. You've got their calculator. So the perimeter of F should be H, 69? Yeah. And this is the perimeter that I don't know. So you say, let's see, small to big. So 2 to 3 is the scale factor for the perimeter 2. It's going to be the perimeter I don't know compared to the perimeter I do know. So 3x equals 2 times 69. That will divide by 46? Yes? Right? Well, that is doing the same thing. Multiplying both sides by 69. If you don't want to use cross products, you don't have to. You'll just solve the equation really well. But the important thing here is that that 2/3 applies to perimeter. It's a lot more work to figure out all those sides than just using that perimeter. So questions on that? That's kind of a big deal. It is. Okay, let's see. So we have 2 polygons, CDEF and QRST. And I can just draw them any way I like. I don't know much about what they look like. But when I letter them, put the IDs on them, the points, C, D, E, F, I'm going to do this one the same way, Q, R, S, T. So however you letter them up, do it in the same order. They are similar, it means they have the same scale factor. This perimeter is 56. What else do you know? We also know that DE, this guy here, is 20, and RS is 15. They want this perimeter of the other figure. So I have one set of corresponding sides. I'm told they're similar. So it's going to have a scale factor of one side to the other. It looks like I'm going big to small. Even though my figures don't support that, I'm going by what the numbers tell me. Divide by 5, yes. So 4 to 3. Going from this triangle, or this, I'm sorry, quadrilateral, to this one. That's the scale factor. The ratio of the perimeters will be the same. So this one has a 56, and this one is, I don't know. So make sure you're going in the same order. This is CDEF to QRST, CDEF to QRST. 4x equals 3 times 56. Divide all that by 4. Okay, I'm here, right? And then I divide by 4. So it looks like x is 42. Is that right? And what did I find? The perimeter of this guy, 42 units. Question so far? So working with similarity and working with scale factor. Now, proving triangles similar. We are experts at proving that triangles are congruent. So now we're looking, how do you know if they're similar? So what are our rules with triangle congruence? Do you remember what all the things are? I know it's written there, but without looking, what are all the different triangle theorem, 3-letter notations we have? Joseph? Without looking at the paper. Do you know by heart? No by heart? You do. Come on, go ahead. SSS, SAS, A is A. Two more. Listen, notice which one you missed. Do you remember, Lauren, which one you missed? Hypotenuse leg. And do you remember the one you missed?
AS.
Angle, angle, side, right? So we have to remember those 5 things to use for triangle congruence. Well, for triangle similarity, we have less things to remember, which is good. So to prove triangles are congruent, this is kind of the definition, that the corresponding angles are congruent and the corresponding sides are proportional, meaning the same scale factor. Okay, that's what that means. So postulates and theorems, eh? Okay, so we have angle, angle. 2 triangles are similar when any 2 sets of corresponding angles are congruent. Remember how this was one that did not work for? Well, we had angle, angle, angle was one that did not work, remember? Angle, angle, why only 2? How come only 2, Phil? Right. So we basically proved our, what is that, third angle congruence theorem? Just proved it for us again. So if you know 2 angles are congruent, then it must be that that third angle is congruent. So we don't need to say it. We don't need to find it. If you find 2, good enough. Not good enough for congruence, but good enough for similarity. We also have side, side, side. Now we don't want to confuse this with the triangle congruent side, side, side. Triangle congruent side, corresponding sides are congruent. With proportionality or similarity, they are in proportion. They have the same scale factor. So if you can show that all the corresponding sides have the same scale factor, then you have 2 similar triangles. Okay. And we also have side, angle, side. So again, not to be confused with the congruence theorem or postulate, side, angle, side says that as long as that included angle does have to be congruent, but the sides are in proportion. And what does that mean? They have the same scale factor. So 2 sides of a triangle, corresponding sides, have the same scale factor, and the included angle is congruent. You have similar triangles. All right, looking at some examples here. Find 2 congruent angles. So I'm on page 2, kind of in the middle-ish, top middle. And then we already answered this question because of the third angle congruence. Okay. So let's see. Do I have similar triangles? Now looking at these angles, I have one. I can see one that's congruent, but I don't see 2. But wait a second. What is the third angle for this one? What's the value of that third angle for that smaller triangle? I want everybody to have a chance to come try it. Get into that third angle. What? 50 degrees? So look, this one is congruent to that one. I've got angle, angle, good enough. These are congruent. I could find this other one, right? I know it's going to be 45. So I can see they are all congruent. So angle, angle, similarity, that's why they are congruent. The way you would write the similarity statement, triangle, J, L, K, similar to triangle, now I'm matching up the measures, Y, X, Z. So I want to make sure that I've got them all matched up. Okay, can I find 2 similar triangles in here? Does this say find 2 congruent angles? I love that. Just notice that. In your notes, it should say similar. Just notice that. Right, I'm looking for similar. I don't have congruent. So that's the angles. Oh, angles. Okay. Sorry. I got myself all confused. I am confused today. Okay, so, but I do want similar triangles. So let's see. What have I got here? I see parallel, parallel. Do you have any angles that are congruent? What do we see? Why? Right, so which one is this? What kind of angles are these? They're corresponding angles of parallel line. So these are congruent. Well, so are these, right? So I do have two angles that are congruent, so I've got an angle similarity. Now what are the triangles? This one and the big one. So these are my similar triangles. You also could have said angle J by a reflexive property. You would have chosen any two of those. You've done it. So it's triangle JKM is going to be similar to that big guy, JLM. Angle similarity. And then what is this guy? Oh, okay. Let's see what we got going here now. This one's a little more complicated. You know, whenever I see they give me two angles, it should become an automatic. What's that third one? And I think we're using the same measures as we had up here. So this one's 45 and this one's 50. Then this little PTQ, right, is going to be 85 degrees. So I can see this little triangle. Is there another triangle? Now this triangle. Big one. I go all the way around this way. Right? Oops, hold on, there we go. So what's this measure here? Oh, wait, what's this one? That's going to be the same as the other one, right? So that one's 50. Then in the small one, it's 50 for the big one, and then this one is 50, 85. This one's 45. So do I have similar triangles here? They're a little harder to see, but yeah, so here's like this one's similar to that one. This is similar to itself, or congruent rather, and that one's congruent to that. What would the similarity statement be? Triangle, let's say triangle PRS. PRS, similar to triangle, which one? How would I word it? Right? That's the small one. Yeah? Does that match up? Is P is 50, R is 85, T is at 85, right? So I'm going to have to go this way. And then S is 45, so Q is S. So you have to kind of match them up. And once you do that, you can see similar sides. PR and PT similar. RSTQ similar. Okay. Awesome. Side similarity is slightly more complicated. You're going to look for equal scale factors now. So here's three different triangles, and they can get very confusing, like what the orientation is. So my advice, look for the small, the medium, and large sides on each. Small, medium, large, small, medium, large. And kind of labeling that, because look, they're not all the same. So what you do is I have to compare all the sides. So I'm working with now with these two triangles. So are these two similar? So let's see, it says the longest one. The longest one would be 12 to 15, which I can reduce that to, I don't say 4 fifths. The medium ones would be 9 to 12. And when I divide that, I get 3/4. I'm really not looking good. Just finish it for completeness. But I think I can see already that even though these two sides are in proportion, this one is not. Because all the sides are not in proportion, I do not have side similarity. These two not similar. So no and no. Now let's look at this one and this one. I'm looking at these two, left and right here. So longest side, 12 to 20. And what is that? Divide by 4, yep, 3 fifths. Medium would be 9 to 15. Divide both by 3 fifths. So far, so good. Largest to, smallest to smallest, 6 to 10. Would be, divide by 2, 3 fifths. Scale factor, scale factor, scale factor. The scale factor from this one to this one is 3 to 5, and I do see side similarity, so these are similar triangles. And then we have two pairs left. Oh, all right, so large to large, 15 to 20 would be divide by 5, 3/4. Medium to medium would be 12 to 15. Divide by 3. We're not looking good. And then big, small to small. 6 to 10. Am I doing that right? No, this one. 6 to 10. Going wrong. 8 to 10. Still doesn't work. I knew way that this was a no just from the first two. So when you're looking for side-side-side similarity, all the corresponding sides must have the same scale factor. Question? So it's a little bit, I like this little table, it just helps me compare what's going on. Looking at side angle side, I need equal scale factors and congruent angles where this is an included angle, meaning it's in between the two sides that are in proportion. So I want to know, and this is an example near the bottom of the page, are these similar? Well, I already see that I have an angle that is congruent. That's good. So I have to know that the included, or the sides that make it the included angle are in proportion. So this one to this one, and this one to that one. So this is a longer, and this is a smaller. So far that's good. If that didn't work, I would kind of know that they're not. But let's see, scale factor longer to longer is 28 to 16. Divide by 4, yes? 7 to 4? Let's try this one, shorter, shorter. So 21 to 12. I can divide by 3. That looks good. In proportion, in proportion. Yes, the included angles are congruent, so yes. That's what a side angle side similarity looks like. Yeah? What do you guys think? So there is a lot of figuring, just a lot of figuring. Okay. Now this, I think in geometry, the next thing is like the most important question ever asked in geometry, because every geometry class wants to know this. Classic question. Black hole height. We are stumped. We need to know how tall black holes are. I don't know why, but we do. And we can, luckily, because now we know triangle similarity. So on a sunny day, you're standing in front of Eagle Ridge. Say like today. So a friend, here you are, look at you. Here you are. A friend measures the length of your shadow. Your shadow is 4 feet. She also measures the flagpole. Okay, so that shadow is 29 feet. You're 5.5 feet tall. So here you are at 5.5 feet. You want to know the height. Now, of course, conditions are perfect. The ground is perfectly level, and these are all right angles. Okay, so I have that angle similarity. So all I need to do is just do like a kind of a side angle side comparison here. So this says the scale factor from the shadows should be the scale factors of these heights. They should be the same. So that says 4 to 29 feet should be the same as your height to my unknown flagpole height. So I can just set that guy up just like this. So I'm going to use cross product. So 4x is going to be whatever 29 times 5.5 is, which 159.5. Am I doing that right? And then divide both sides by 4. So let's see what the height of that flagpole is. I get like some number like this, you know. So we went, yeah, I found it. The flagpole is 39.875 feet. You know, what would we say? I think we would say 40 feet, right? Now, it's not telling you how to round this. I'm not going to get mad at you if you left it like this. But, you know, what would we really say? How tall is that flagpole? It's about 40 feet tall. 40 feet tall. Question?
Yeah.
What's your question?
How do you know if those triangles are similar?
Well, we're working, you know, that's a good question. We are working on the assumption perfectly level ground and perfectly level everything. So that we're making them nice similar triangles. What? Yes. But we can get close. So the idea is if you're estimating something, maybe conditions aren't perfect, but you might get a close idea. So the best you're most likely going to do in real life is an estimate. So for the example we're doing here, which is kind of fun a little bit. Now in the beginning, I gave you 2 problems on the now. These were in the beginning. This was on the front chart. Can we find out how tall the tree is? So let's see. Susie is 5 feet tall, and she's making her earlier.
I don't know. I can't find.
8 foot. I think that's an 8-foot shadow.
Yeah.
This is not in the notes. Okay. Now she's 10 feet away. So let's see. If she's 5 to however tall this is, and her shadow is 8. What's the shadow of the tree? 18, right? It's not just 10. It's that whole thing. is gonna be 3 to 30. This one they are giving me the whole thing here. So 3x equals 60